I can solve problems by writing and solving linear equations in one variable. Here's what you need to know. Sometimes formulas are used to write expressions and equations, so we can translate from English words into like math language, letters, numbers, and symbols. Here are some common formulas that you've probably seen before. We have the area of a rectangle, length times width, the perimeter of a rectangle, twice the length plus twice the width, the area of a triangle, 1/2 times the base times the height, and distance is measured as the rate or the speed that you're going times the amount of time you travel. And here are the steps that we're going to use when we are working out a word problem. We always start by identifying the actual problem. What are we trying to find? Then gather information, figure out what you already know, write an equation to represent the information that you've been given, then solve that equation to find the value of the unknown or the variable, and then check your answer to make sure that it makes sense, not just mathematically, but logically as well. So if it said how many people were standing in line and you solved something through and you got like 3.2 as your answer, you might need to check your work because I've never seen 3.2 people. Let's work out example 1. Julie and Avery are going out to eat after the football game. Julie leaves the game at 8:30 and travels at 50 miles per hour to the restaurant. Avery leaves the game at 9 o'clock and travels at 60 miles per hour to catch up. How long will it take Avery to catch up to Julie? And we're going to assume that neither one of them stops. We're trying to figure out the number of hours that Avery is traveling because it says how long will it take him to catch up. So we're figuring out the number of hours that Avery is traveling. Distance is equal to rate times time, so we're going to use that information in this problem. What we just did in this box number 1 is we identified the problem. We figured out what we are looking for. Next, we're going to gather our information. So step 2, here's what we know. We know that Julie and Avery's distances are equal. They both left the football game and went to the restaurant. We're assuming that they went the same route and neither one of them stopped. So the distance that they travel is equal. So we can say the distance that Julie traveled is equal to the distance that Avery traveled. Step 3, let's write an equation to represent the situation. The distance for each person can be rewritten as rate times time, because right here, distance equals rate times time. So the distance that Julie traveled is her rate times her time, and we know that her distance is equal to Avery's distance. And Avery's distance can be written as his rate times his time. So we've got the distances are equal. That means the product of their rates and times are also equal. We're going to plug in the values that we already know. Julie left 30 minutes before Avery, so she has spent a half hour longer traveling than Avery did. She left earlier, she's been in the car longer, so I know that her rate is 50. She's been in the car for the amount of time that Avery travels plus half an hour more. And then we're going to plug in 60 for Avery's speed. And we already defined our variable h as the time that Avery spends traveling. So now we have an equation. We filled in what we know from the word problem. We're going to solve this equation for h. And this 1 right here, I'm not quite sure, it should be a 0.5. Right here where I'm hovering, this should say 0.5. Something weird happened in this PowerPoint. Everything else is correct. So we use the distributive property and get 50 times h plus 25 when I distribute, and it equals 60 times h. I'm going to subtract 50h from both sides to get 25 equals 10h, and then divide both sides by 10, and I get that the number of hours is equal to 2.5. So that says Avery traveled for 2.5 hours, and we're going to plug in that 2.5 for h just to check that it works. So Julie went 50 miles per hour for 3 hours because she went half an hour longer. Avery went 60 miles per hour for 2.5 hours. Must be a really good restaurant. They're willing to travel that far just to go out to eat. Since we get a true statement, we know that our solution does work. Let's try one that's a little bit more simple. Go ahead and pause and try this one using the steps over here on the left. I also have the equation up here that you will need to solve this one. Let's check our work. A rectangle has a length of 3.7 inches and a perimeter of 20.2 inches. What is the width of the rectangle in decimal form? So we're going to start by identifying the problem. We're trying to find the width. Let's let that be W. Step 2, figure out what we know. We know that the length is 3.7 and the perimeter is 20.2. So let's plug in what we know and write an equation. Perimeter is 2 lengths plus 2 widths. So 20.2 as the perimeter is 2 times the length plus 2 times the width. And we're going to now solve that equation for W. Hopefully you got 6.4 as your answer, and we can plug that back in to see if it works. Since I'm getting a true statement after I evaluate, I know that my solution is true. If you want more on this topic, be sure to check out the Learning Target spreadsheet for extra resources, videos, and practice.